Welcome to the audio-visual presentation on microcephaly. Microcephaly is a neurological condition where an infant's head is significantly smaller than the heads of children of the same age and sex. It often indicates that the brain has not developed properly or has stopped growing. This presentation explores the causes, embryology, clinical manifestations, diagnosis, consequences, prognosis, and associated syndromes of microcephaly. Causes. Microcephaly can result from a variety of genetic and environmental factors. Common causes include 1. Genetic mutations. Mutations in genes responsible for brain growth and development can lead to microcephaly. 2. Infections during pregnancy. Infections such as Zika virus, cytomegalovirus, rubella, and toxoplasmosis can impair fetal brain development. 3. Exposure to toxic substances, alcohol, certain drugs, and environmental toxins can interfere with brain development. 4. Malnutrition. Severe maternal malnutrition can lead to developmental issues, including microcephaly. 5. Disruption of blood supply to the baby's brain. Conditions such as placental insufficiency can reduce the supply of oxygen and nutrients. Embryology. During normal embryological development, the brain and skull grow rapidly, and this process begins early in pregnancy. Around the 4th week of gestation, the neural tube, which eventually forms the brain and spinal cord, closes. This is a crucial step in brain development. Following this, the forebrain, midbrain, and hindbrain start to differentiate and expand, and by the end of the first trimester, the basic structures of the brain are formed. As the brain grows, the skull bones also grow in response to accommodate the expanding brain. This rapid growth continues through the 2nd and 3rd trimesters. Any disruptions in these stages, whether due to genetic factors, infections, exposure to toxins, or other environmental influences, can impede normal brain development and result in microcephaly. This means that the brain and skull do not grow to the expected size, leading to the characteristic small head size associated with the condition. Understanding these developmental processes is essential in grasping how microcephaly occurs and underscores the importance of a healthy prenatal environment for optimal brain development. Clinical manifestations. Children with microcephaly often exhibit the following clinical features. 1. Small head circumference, a head size significantly below the average for age and sex. 2. Developmental delays, delayed milestones in motor skills, speech, and cognitive abilities. 3. Intellectual disability, ranging from mild to severe, depending on the extent of brain growth impairment. 4. Seizures, many children with microcephaly experience seizures. 5. Movement and balance issues, these can include hyperactivity, clumsiness, and poor coordination. Diagnosis. The diagnosis of microcephaly involves several steps. Prenatal diagnosis. During pregnancy, microcephaly can be detected through routine ultrasound scans, typically in the 3rd trimester. Abnormal head size measurements can prompt further testing. Postnatal diagnosis. After birth, the diagnosis is confirmed by measuring the infant's head circumference and comparing it to standardized growth charts for age and sex. A head circumference significantly below the average can indicate microcephaly. Imaging studies, MRI or CT scans can provide detailed images of the brain to identify abnormalities in brain structure and development. Genetic testing. If a genetic cause is suspected, tests such as chromosomal microarray analysis or whole exome sequencing can identify specific genetic mutations. Infectious disease testing. If maternal infection during pregnancy is suspected, tests for infections like Zika virus, cytomegalovirus, and others can be conducted. Consequences. The impact of microcephaly varies widely. Potential consequences include: 1. Learning disabilities. Most children will require special education services. 2. Physical disabilities. Some may need assistive devices for mobility. 3. Behavioral issues. Hyperactivity, aggression, and difficulty with social interactions can be common. 4. Neurological problems. Ongoing issues such as seizures and spasticity can affect quality of life. 5. Feeding and growth problems. Difficulty swallowing and poor weight gain can occur. Prognosis. The prognosis for children with microcephaly depends on the severity of the condition and underlying causes. Children with mild microcephaly and no other major abnormalities may have normal intelligence and development. Severe cases often lead to significant neurological and developmental issues, requiring lifelong care and support. Early intervention with therapies and educational programs can improve outcomes for many children. Associated syndromes. Microcephaly can be part of several genetic syndromes, including 1. Zika virus syndrome, characterized by severe microcephaly, vision and hearing problems, and joint deformities. 2. Seckel syndrome, a genetic disorder marked by dwarfism, intellectual disability, and distinctive facial features. 3. Smith-Lemli-Opitz syndrome, it involves microcephaly, intellectual disability, and physical malformations. 4. Chromosomal abnormalities. Conditions such as Down syndrome and trisomy 18 can include microcephaly as a feature. Thank you for your attention. For further reading and resources, please consult relevant medical literature and trusted health information websites.